So our topic is the binary number system, but to understand what the binary number system is, first you have to understand the decimal system. So the decimal system is the most commonly used form of math. It was invented around 287 to 212 BC. It's used to count things. It's also used through like kindergarten math and even below that, all the way up through calculus. There are 9 digits in the decimal number system: 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is also called the base 10 system. To understand the basics of the binary number system, first you need to understand the basics of the decimal system. So for a number like 125, you have 3 places, but these places can go up depending on what the number is. So we have the ones place, the tens place, and the hundreds place in this number. In the ones place, we have 5 ones. In the tens, we have 2 tens. And in the hundreds, we have 1 100. And so when you add 5 ones, 2 tens, and 1 100 together, you get 125. This is kind of a bigger number, but we can also use it for smaller numbers, like 25. In this, you would have 5 ones and 2 tens, and you get 25.
Alright, well, now that Caroline has explained the decimal system, we're going to jump in to learn about the binary number system. So the binary number system is also known as base 2 because there are only 2 numbers that are used, 0 and 1. And the binary number system is actually used for computers, and it is easier for the computers to understand 0 and 1 because it's either off with 0 not being there or 1 on. And they haven't found a computer system to deal with the decimal system when there's up to 9 digits, and it can be very complex. So this is what we deal with today. And so as we explained, using 125 in the decimal system, and it's base 10, so you have 5 times 1, because 1 is in the first decimal place, the ones place, 2 times 10, which is in the tens place, and 1 times 100. If you add them all up, you get 125. So we're going to try to mimic what we did over here. And so instead of having 10, because the reason why this is called base 10 is because the base for each decimal place, as you go on the number, is using a base 10, and this is base 2, so we use 2 as the base here. So each base is squared like we did over here, because this is really 10 to the first power and 10 to the 0 power, and everything to the 0 power is 1. And then this is 10 squared. So then we're going to go over here and we use 2. So 2 to the 0 power is 1, 2 to the first is 2, and we go down the line, and these are our base numbers. So we have, when we're converting from the decimal system to the binary system, here are the 3 steps. Number 1, you subtract by the closest number and put in 1 for the answer, because it's either there or it's not in the binary system, so it's 0 or 1. So if we're using 125, the closest number is 128. But if we subtract 125 by 128, we're going to get negative 3. In the rule, you can't have a negative number in the binary number system. So we're going to go to the next number, which is 64. So we have 125 minus 64, which equals 61. So that's what we did first step. The second step is find the next number and subtract by our next decimal base. So the next one is 32. So we have 61 right here is our answer. We're going to have 61 minus 32, which then equals 29. And then 3, repeat step 2 until you finish. So you just go through this one, and as you can see, as it's only there once, you put a 1 in for the number. So then, for here, when we have 0, we'll just skip all the way down to the end, where we have 1. This step, our remainder becomes 1 minus 2, and then if we actually subtract this, we would get a negative 1. And since the rule is that you can't have a negative, we would have negative 1, and we just put 0 in for that one. And then we carry, and then so we just keep the same number of 1. 1 minus 1 equals 0. And then at the end of this process, if you don't equal 0, it means you done something wrong or something went wrong in the process. and that's when you're done, and you one in the last digit, and that is it.
So now that we understand binary, we're going to do some examples. So we picked the number 34, and we're going to start off using the decimal system or base 10. So with our number 34, we have 2 digits, one in the ones place and one in the tens place. This can be represented here, which we have 4 times 10 to the power of 0, which is 1, because 4 is in the ones place. And then we also have 3 times 10 to the power of 1, which represents the 3 being in the tens place. And so we essentially have 4 plus 30, which is equal to 34, which is the number that we're looking for. So the first step, which is subtract by the closest base number, we know that we can't use 64 because 32 minus 64 is a negative number, and as Drew told us, we can't have negative numbers. So the next closest one is 32. So we subtract 34 from 32 and get 2, so we put a 1 here. And now all the way down until 2 to the power of 1, we have to put zeros because we have 2 minus the next closest base number, which is greater than 2 in all of these instances. So we put 3 zeros here until we get 2 to the power of 1. And then we can do 2 minus 2 equals 0, so we put a 1 here. And then, because the third step is repeat until we have a remainder of 0, and we have a remainder of 0, so we just put a 0 in for the last box. And then you're done.
Okay, so now that we have gone from the base 10 system, which is the decimal system, to base 2, the binary system, we're going to try to go from binary number back to decimal number. So here's our binary number. It's 110011. So as we know, this is the first decimal place here is 2 to the 0. The second one is 2 to the first, 2 to the squared, 2 third, 2 to the fourth, and 2 to the fifth. So what we're going to do is we multiply the number that we have by this base number. So over here, we'll start, this is the ones place, so we'll go from lowest to greatest. So 1 times 2 to the 0 was 1, so we're going to do 1 times 1 equals 1. And then this is going to be our column where we add them all up to find our decimal number for the base 10 system. So then we have 1 times 2 to the first is 2, so we have 1 times 2 equals 2. Then, since we have zeros in for the third and fourth decimal place, which is 2 squared and 2 to the third, the two base numbers, it's the way the computers work is that it's either there or it isn't there. And since neither of those are there, it's just we would multiply by 0 and we would add 0, so we're going to be lazy and efficient not to put those in. So we're going to go straight to the next one, which is 2 to the fourth, and 1 times 2, and 2 to the fourth is 16, so that is 16, and then 2 to the fifth, then we're going to multiply by 32, because 2 to the fifth is 32, and then when we add these all up, this is 8, 48, 51, I think. So this is the number in 51 in the decimal system is 110011 in the binary number system, and that is how you convert back and forth.
So before we end, we just want to finish up with some fun facts about binary. So it was discovered by Gottfried Leibniz, and essentially it was discovered in like the 17th century or something like that, and now it's being used in computers as a computer language, so it's basically just old math being reused.
Right, so right nowadays for math, it's being used for coding in computers. As I said before, the two numbers are 0 and 1, so the computers can easily identify numbers because it's either there or it's not there. So, and then the computers can, as us as humans, can configure between decimal and binary. So it's used for coding and other computer programs. And you can go up to infinite powers of 2. So because if you ever notice, the binary numbers are a lot longer than the decimal numbers. So when you're converting, you can get binary numbers up to like the 16th power and keep going in for like thousands in the decimal system. So the numbers in the binary number system can be a lot longer than the other ones. Okay, so now we're gonna divide out of. Hate this. It's okay. It's fine. Yeah.
How to transition.
No, I know. I feel. Divided by 4, which is 2 squared is our next number. Goes in ones. 1 times 4.
I believe I can fly. I believe I can touch the